Hi guys, welcome back to my channel. It's the educator here, and in this video I am starting a new series where I am going to be teaching MTH112 right on my YouTube channel. This one you are currently on. If this is your first time turning into this channel, please do want to hit the subscribe button so that subsequent videos I am going to be dropping, you are not going to be missing out. Okay, so it is not only MTH112 I have done this video for. I've done this video for PHY 111 to 111 by 111 CHM 111. So any of these courses that you'll be offering, ensure you check out the videos. Just go to my YouTube channel, check out the playlist, and then watch the videos that you are interested in. Alright, so let's dive into this video. So for MTH112 is all about statistics and probability. And then in this particular video, our concentration is going to be on descriptive statistics. Alright, so we're going to be looking at descriptive statistics. Right, so you can see I named it part 1. Okay, so we're looking at introduction to statistics and graphical representation. Alright, let's move on. Definition and scope. Okay, definition and scope of statistics. So the first thing you want to know is what exactly is this statistics? What exactly is statistics? As simple as it may sound, trust me, definition of statistics can come out in your exam. So nothing is too simple or nothing is too hard to. Alright, so as you can see, four important words were used in the definition of statistics, and it is very, very important for you to include these words when defining statistics. So the first thing is to collect. The data will be collected first. Then secondly, after collecting this data will be what? Analyzed. Or sorry, it's going to be organized. You are going to organize the data you have collected. You don't want to work with the scattered data. So the next thing is to organize. And after you organize, you come out with a summary, after which you analyze this data, because the purpose of you collecting this data is not just for collecting sake, it's for you to analyze it. Okay, so at 100 level now, we're going to divide statistics into two branches. So we have the descriptive statistics and the inferential statistics. So just as the name implies, that is what it means. Descriptive to describe, inferential conclusion. So what exactly does this mean? Descriptive statistics, method used for organizing and summarizing data through the use of tables, charts, averages, each creating a pie chart of a class grade and so on and so forth like that. So when we use charts, tables, average, mean, median mode and stuff like that, that type of statistics is known as descriptive statistics. You are trying to describe. Okay, and now for the inferential statistics, it is when we use a small group, that is for sample, a small group known as sample, to make educated guesses or prediction about a larger group. Okay, so all these laws that exist currently, for example, if they say if you pour a water on a plant, it is going to grow. Somebody did that experiment, and now the person did not carry out that experiment on all the plants on earth. The person just selected a few plants and then conducted the experiment and discovered that, oh, water is actually a necessity for plants to grow. All right. So that kind of statistics is known as inferential statistics. That's just an example, by the way. Language of data classification. So before a student can draw a graph, they must identify the nature of the data they are working with. Okay. So before you can draw a graph, before you can analyze, you must understand, you must know what kind of data am I working with. So the first one we have is qualitative data. This qualitative data, categorically, these are non-numerical description. So it's not a number, it's not something based on number, maybe 2, 3, 4. Okay, quality. That's where we have blood groups, for example, we have genders, we have marital status. You can say all these things are not numerical descriptions, right? So we classify them as qualitative. And now we have the quantitative, which is the numerical. Quantitative, when you're quantitative, has to do with number. Okay, so data that represents count or measurement. So something that we can count, something we can measure, we classify it as quantitative. Okay, so under this quantitative, we now have two description. We have two classes. We have the discrete and then we have the continuous. So what exactly is discrete? Values that can be counted and usually whole numbers are known as what? Discrete. For example, number of students in a hall. Number of students in a hall will definitely be a whole number, right? So maybe there are 6 students in the hall, there are 62 students in the hall, there are 623 students in the hall, right? You will never see something like there are seven, there are 7.5 males in this class. It does not make sense. So that is what we know as a discrete quantitative data. Then we have continuous. So these values or these numbers or this data can be represented in decimal fraction, can be represented not only in whole number. For example, height, weight, temperature. Okay, height, we can say the height is 7.5, 6.2, 3 points. So this does not mean it cannot be whole number. It can also be whole number, but then continuous can also be expressed in decimal and fraction. While discrete is only whole number. All right. So moving on, we have visualizing data. That's graphic representation now. So we understand how to interpret which data is which. So the next thing is what are the ways we can represent this data. Okay, so graphs are storytellers of statistics. They make hidden patterns visible. All right, so we have various methods to represent data. We have bar chart, which is common. Okay, it is best for qualitative or discrete data. Okay, crucial point: the bars do not touch. Okay, so if you have a bar chart like this, for example, you have a bar chart like this, and then you have something like this, something like this, something like this. You can see that the bar chart does not touch, right? But then it can also be like this, depending on how you want to do it. You can see also the bar chart is not touching. Okay, we use bar chart to analyze qualitative or discrete data. So you can see this is another exam question. They can tell you which graphical representation is best for qualitative or discrete data. Please take note, it is your bar chart. Okay, so just in case you are wondering that, oh, this slide I'm using to teach this lesson is concise and easy to understand. Okay, it's the material which I made. All right, I made this material and then I am selling this material currently to 100 level students who are interested. Okay, so if you're interested in purchasing this material, please do what we indicate in the comment section. The material has all the topics you'll be doing for this semester alongside with possible exam questions, worked examples, and anything you can think of that a material should have. So currently it is selling at a discount price of 1,999 naira. After which it will go back to the original price, which is 4,000 naira. So you have the opportunity to buy it at a discount price right now. So as soon as you watch this video, don't waste time, because anytime you waste further, the price is going to return back to the original price. Okay, so let's come back to the lesson. The next one is histogram. Histogram is best for continuous data, right? We use histogram to represent continuous data, and we already know what continuous data are. And then the bars must touch. Please take note to show the continuous nature of the measurements, right? Then we have pie charts. Pie chart is used to show how whole is divided into parts, right? It's used to show how whole is divided into parts. Okay, for example, we have set of boys in the class, and then this set of boys bring certain amount to the class, bring certain amount to school. So we have A brings 2 naira, B brings 5 naira, C brings 10 naira, and then D brings 4 naira. Now this is a very very good example of a data that we can use pie charts to solve. Okay, we can use pie chart to represent these data. So, oh, how many percentage of money, or what is the amount that so person brings to class, and then because it is pie chart, it is a circular format, and then in this circle we have various angles. We have various angles, right? There's a formula for calculating the angle. The formula for calculating the angle is frequency over total frequency times 360. What does this mean? A is what? 2, right? So the angle, if you want to calculate the angle for A, it will be 2 divided by, what's the total here? 2 plus 5, 7 plus 10, 17 plus 4, we have 21. So that will be 2 divided by 21. times 360. That's how we get the angle. But then if they say get the percentage, it will be what? Times 100. Please take note of the difference. To be times 100. All right, so moving on, organizing raw data. Organizing raw data. Okay, so to make data ready for graphing, we use frequency distribution table. So there's what we call a frequency distribution table. And in a frequency distribution table, there are things that you will find in the frequency distribution table. And these things include number one, your class interval. So what exactly is class interval? So it is the grouping of data. All right. So if you have a very, very large data that you want to analyze, maybe over 1,000 or over 5,000, you can't start doing individual analyzing. If not, you just end up wasting your time and stressing yourself. So what you need to do is to group them, group the data. So you can say maybe 10 to 19, 20 to 29, 30 to just like that, and it continues. So this is known as the class interval. Then we have class boundaries. Okay, so these class boundaries ensures that there is no gap in your histogram. All right, so you can see another possible exam question will tell you which organization of data allows no gap in histogram. You should know it is a class boundary. So it's because we have class boundaries, that is why we don't have gaps in histogram. Okay, so midpoint, we have the midpoint represented as x. So this is the center of a class interval. Center of a class interval. The center of a class interval is the lower limit plus the upper limit divided by 2. So this is the class interval here, 10 to 19. The lower is 10, the higher is 19. So 10 plus 19 divided by 2, we are going to get the midpoint. All right, so please just take note of all these things. These are the basics that you need to know before you go into the main statistical work. All right, so now moving on to the next, which is this concept of centrality. Concept of centrality. All right, so a measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within that set. It is the typical value of the distribution. So you can see from this particular definition, there are already two exam questions that can come out to tell you what is the typical value of a distribution. You should know it is the measure of central tendency. So measure of central tendency is basically you using a single value to describe a set of data. All right. So while describing the set of data, the technique you use is by identifying the central point within the set. Okay. So as we move on, you will understand what this concept of centrality means. So for measure of central tendency, we have the arithmetic mean. The arithmetic mean falls under the concept of centrality, which is measure of central tendency. So the mean is the most common measure of center. You know, right? Mean. Or if you don't know, we are still going to prove it in this lesson. So it is calculated by summing all the values and dividing by the total count. Okay. So for ungroup data, we have the summation of x divided by n. So for example, if I have 2, 3, 4, 6, 5, and 7. So and now I'm asked that I should calculate the mean. I should calculate the mean of this guy here, this set of data. How will I do it? What I need to do is to plus all of this. So I'll do 2 plus 2 plus 3 plus 3 plus 4 plus 6, right? Plus 6 plus 5 plus 7, and divide by the numbers of sets. So what is the number of sets? 1, 2, 3, 4, 5, 6, 7. 7. Please, it is not this 7 here I'm using. It is the total number of sets that I used, 7. So by the time we do this, 2 plus 2, 3 plus anything we get and divide by 7, that is the mean for ungrouped data. You can see this is ungrouped data. So when we say ungrouped data, it means that the data is not grouped, right? It is not grouped like this. Let's go back. You can see this organization of raw data. This is group data, group organization, group organization. You can see this class interval here, groupings of data, right? Group organization. So now for group data, how do we calculate? Now, when you see a frequency table, you are given a frequency table. Okay, when you are given a frequency table, you can use the class midpoint and frequencies to calculate the mean, right? So let me say for all of this data here, we now have a frequency. Let me put the frequency on now. Let me say the frequency for 2 is 1, frequency for 3 is 6, frequency for 4 is 5, frequency for 6 is 10, frequency for 5 is 2, frequency for 7 is 3. Now, how are you going to find the mean for this group data? So let me see, we have converted this guy now to a frequency table. So this is a frequency table now, right? Let's convert this to a frequency table. Frequency table. This is now a frequency table, right? So how do you now calculate it? When you see questions like just know this is a group data, all you need to do is to this is the formula here. So you do fx. Normally this is x and the frequency is always f. So what this means is f times x, which is 1 times 2 plus 1 times 2 plus 6 times 3 plus 7 times 4 plus 10 times 6, and just like that you do it, and then you divide by summation of the frequency. This is the summation of the frequency. So we add all of this number here, and then we divide it and we get the mean for the group data. So just in case you are wondering why there is no worked example in this lesson, the reason is because this lesson is just to create an exposure to everything that you will see in your MTH 112 possible exam questions and how to approach them. Okay, if you are looking for a worked example, I have created a material. The material I talked about previously, I have outlined a lot of worked examples there with a lot of questions that you can use to practice. Okay, so do well to get that material. But then if you want me to make a separate video where I'm going to explain worked examples, like I'm going to set questions, calculational questions, and then solve it, please indicate in the comment section. Once I see that a lot of persons are interested in that, I'm going to make that video. And then the only way I'm going to also make that video is if this particular video gets a lot of engagement, nothing less than 1,000 views. Alright, so if I can get 1,000 views for this video, then I'm going to drop a separate video for the calculations. Okay, so let's proceed. Now we have the median. The median. All these concepts are simple and common concepts that you must have seen in your primary school or secondary school days when you were doing mathematics, right? So for the median is the middle value. We know that, right? Median is the middle value. We already know that. So when data are arranged in ascending or descending order, please take note, this is the criteria. When data is arranged in ascending or descending order. So this means that if the data is not arranged in ascending or descending order, your work is to arrange it in ascending and descending order. Then you pick the middle. But if you have two means, or rather, if you have two middle number, what am I trying to say? Maybe 1, 2, 3, and 4. Then let's find the median. You know that the median is these two because these two are in the middle, right? The median, these two are in the middle. What you need to do is to plus these two together and divide by 2 to get your median. Alright, so now for group data, this is for ungroup data. This one I just explained is for ungroup data. Now for grouped data, this is the formula for solving median for group data. But not to worry, you don't need to stress yourself learning this formula because most likely for the nature of your exam, they wouldn't ask you the median of group data, but then you should have that at the back of your mind. You should just know this formula just in case. Okay, so moving on, we have the mode. The mode is the value that occurs more frequently in the data set. All right, so let me go back to that my frequency table. Okay, this one here. Now, this one here, this table here. Now, if they ask you what is the mode of this table, it is definitely 6 because 6 has the highest frequency, which is 10. Right? That's the highest frequency, which is 10. So anything that has the highest frequency is the mode. But there sometimes we used to have 2 modes, 3 modes, and stuff like that. If you have 1 mode in a data set, it is known as unimodal. If you have 2 modes, it is known as bimodal. And if you have 3 or more modes, it is known as multimodal. Alright. So let's move on. We have the concept of variation. Concept of variation. Okay, so variation describes how much the data spreads out or scatters. So this is another likely exam questions. Okay, how data spreads out or scatters is known as variation. But then there's a condition around a central position. So this means that this is still under centrality in a way because we're using central position to see how this data is going to spread. Okay, so now this explains why two data sets can have the same mean but different distribution. Okay, that's where variation comes in to tell you how it can spread out or how it can be scattered. Okay, so subsequently you understand what I'm talking about when I say scattered or spread out. All right, so the next one we have is absolute measures of dispersion. As absolute measure of dispersion, this provides a value in the same units as a data. Okay, so under this we have the range. So range is the difference between the highest and the lowest value. This is what we call a range. So highest value minus lowest value will give us the range. Then we have the mean deviation. Mean deviation. So what exactly is mean deviation? So mean deviation is the average of the absolute difference between each data point and the mean. Absolute difference between each data point and the mean. So let me go back to that one, our frequency table, and explain what mean deviation means. So this is what mean deviation means here. Let's say in this frequency table, the mean we got is 4. For example, is 4. The mean deviation, we're now going to subtract. Let's go there. Let's see the definition again. The definition says the average of the absolute difference between each data point and the mean. So we are going to do each data point and the mean. So what this means is, what's the first data? 2. So we do 2 minus 4. 2 minus 4 again, 3 minus 4, 4 minus 4, 6 minus 4, 5 minus 4, 7 minus 4. And then we do it continuously. Then whatever we are going to get, we are going to find the average. Okay, when we find the average, you can see the average. When we find the average, that is known as mean deviation. Mean deviation. Alright, so let's move on to the next one. The next one we have is variance. Variance. So variance is represented as S square. Alright, variance is represented as S square. So let's get the definition of variance. So variance is the average of the squared deviation from the mean. Squaring ensures that the negative difference do not cancel out positive ones. So remember, in mean deviation we did not square, but now in our variance we are going to square. So after we have done this now, for example, 2 minus 4, you know that 2 minus 4 normally is minus 2, right? Minus 2. So what variance is trying to achieve is squaring everything so that at the end of the day, the negative numbers will not cancel the positive number. So by the time we square this, we have 4, right? So at the end of the day, everything is now going to be what? Positive. So that is variance. Now, standard deviation. So standard deviation is more like the square root of variance. So if you know variance, standard deviation is the square root of variance. So this is what I mean. Square root of variance. Square root of variance. You know, square is going to cancel this. So we have this as standard deviation, or S, standard deviation. So variance is standard deviation square. Please take all these things are potential exam questions. Tell you variance is standard deviation square, standard deviation square root, standard deviation divided by 2. So you should know all this. Alright. So moving on, we have the relative measures, which is in brackets coefficients. So this is used to compare the variation in two different data sets. So we are comparing student height and their weight. Right, student height and their weight. So coefficient of variation is given with the formula S over the mean times 100%. So S, you should know what S is. S is standard deviation. So standard deviation divided by mean times 100% is the coefficient of variation. Please take note. Okay, the reason why these formulas are important is because they can give you a question, they'll give you the standard deviation, and then they'll give you the mean, and they'll just tell you what is the coefficient of variation. Now, if you don't know the formula, you come out of the exam hall and say, oh, this lecturer is wicked, blah, blah, blah. But then that is a very, very simple and straightforward question, in the sense that they give you standard deviation. Standard deviation is 5, mean is 6, and they tell you calculate the coefficient of variation. That is just basically 5 divided by 6 times what? Times 100%, and then you get the percentage. It's as simple as that. Okay. So all these formulas, please do well to write them down or take a screenshot of this video so that you will later go back to the formulas. So we have skewness. Skewness. So for skewness, which is also known as asymmetry, so skewness measures the lack of asymmetry, or sorry, lack of symmetry in a distribution. It indicates the direction and degree to which a data distribution leans. So for symmetrical distribution, the distribution is balanced on both sides, right? The mean, median, and mode are equal. That's the meaning for symmetrical distribution. So when you say a distribution is symmetrical, it means that mean is equals to median, median is equals to mode. So if they give you a question, they tell you the mean is 5, the mode is 5. Is this distribution symmetrical? Like, is this distribution normal? Your answer is yes, because they are the same. All right. So moving on, we have positively skewed and then we have negatively skewed. So positive is right, negative is left. So we have PR and L. It might not really make sense to you, but then just know this: PRNL, PRNL. You should know OPQR, OPQR. P and R goes together. Then LMN, L and N goes together. Okay, so please take note. So positive skewed is right skewed. So if they say right skewed, positive skewed is the same thing. They say negative skewed, left skewed is the same thing. So the tail of the distribution points toward the higher values, that's right. Higher values, right? This occurs when a very few scores pull the mean up. Okay, so when mean is greater than median and median is greater than mode, this means that it is positively skewed, right? Which means that the mean is always the highest. Mean is always the highest. If they give you data and the mean is the highest, it means that it is positively skewed or right skewed. But if they give you data where the mean is the lowest, the mean is the lowest, it is known as left skewed or negatively skewed. Please take notes. Take notes. If you look at this arrow, this greater than arrow is pointing to right. So that's another way you should remember. Greater than arrow is pointing to right. And you should remember mean median mode. Mean median mode. That is the order. Mean median mode. So when it is mean greater than median greater than mode, it is right skewed. Then when it is mean less than median less than mode, it is left skewed. Then now the next one we're looking at is kurtosis. Kurtosis, which is the pickedness. Pickedness. So kurtosis describes how sharp or flat the peak of a distribution is relative to a normal curve. So basically, for your level, what you should just know now is the theoretical aspect of all these things. Okay, so nobody is going to give you a curve on the day of the exam, but then even if they give you that, you should be able to do that. But then nobody's going to give you a curve, or nobody's going to give you data and tell you to plot a curve or tell you to plot a graph. Nobody's going to do that. It's going to do the fact that the nature of your exam is a CBT exam. Okay, so but then all these theories you should have them at the back of your mind. Okay, so we have leptocortic, platycortic, mesocortic. You should know all the meaning of these things. Okay, so moving on, we have the mathematical calculation. So to quantify skewness, we often use the Calvert's coefficient of skewness, SK. This formula is a very, very common formula. In fact, your lecturer is going to give you this formula, but then if your lecturer does not give this formula, please take note of the formula. It's a very simple formula to know. 3 times mean minus median divided by standard deviation. So they can give you mean, they'll give you median, they'll give you standard deviation. They'll not tell you quantify the skewness or what is the cow's passing coefficient of skewness. You just shout, hey Jesus, this thing is hard, oh, hey, this thing is hard, oh. But then with the formula, you see that it is not as difficult as you think it is. Okay, and now we have come to the end of this video on the statistics, which we looked at, and then we concentrated on descriptive statistics. Descriptive statistics. So I know you enjoyed this video. Please do well to hit the subscribe button if you have not subscribed yet, and ensure you like this video. Share this video to your friends, share this video to your classmates, share this video to your departmental group chat. Ensure that this video gets the necessary engagement that it needs, so that I'm going to drop the calculational aspect of this video. All right, so see you guys in the next video. Bye for now.